Hi, I'm Justin. I'm gonna try a second episode here with quantum gravitational beginnings is what I'm calling it. Gravitational beginnings, explanation of gravity. Okay, it's a theory of mine, and as I said in my first video, I believe there's a bottom to how small things can get. Point of which nothing can get smaller. Okay. So when we have mass objects, anything that is of mass, it cannot get any smaller than space itself. Now, space, if there's a defined point, it can't get any smaller. How it happens that gravity works and what gravity is. So my explanation of how gravity works and what gravity is, I'm going to hold this here for a minute. So this is just a representation of the smallest. This is space, okay? Can't get any smaller than that. Which basically I'm saying that no two objects can actually touch. They can come close, they can be linked, but not in a physical sense. Some objects can connect with others well, some cannot connect with others well. Different computations of chemicals and whatnot. And we see this in our everyday with the periodic chart, that there are differences out there. So anyway, how gravity works and what gravity is and the beginnings, okay? So everything is bigger than space itself, okay? If space, let's assume space has a bottom. Let's just look at it this way. Nothing can get smaller than a space particle, okay? It's the smallest distance out there, so it's a three-dimensional thing because it's every direction. But nothing can get smaller than it. So when two particles, or if there's a particle that's bigger, I'm going to say that space is similar to a foam, or maybe even you can look at it like water. Foam, okay? Rubber band, there's really many ways to describe it. When you have a massive object, okay, that's taking up space. It's bigger than space is, but space wants that area. It wants that area. It's like when you put a marble in water, the water level will raise a little bit. That marble is actually pushing the water out of the way. Okay, and when you pull that water out, or that marble out, the water goes back. It's retracted. It's comfortable. Now, so this more massive object, okay, since space is trying to get back in there. It's trying to get back in there. So it was there once, and now it's being stretched out. So that's the weak force. Okay, the weak force is space trying to reclaim its area. We could say it creates a gravity well, because what's happening is the weak force is got, now that it's stretched out, it's got constant pressure trying to reclaim its area. Okay, that pressure back in is the weak force. So if I put here a more massive object in space. It pushes space out, it stretches it out. And the force that space is trying to get back in creates the well. It's the force, it's the inward pull to the more massive object. Now, if you get two massive objects, and everything's moving all the time, so if you get two massive objects, they may find each other. And what's going to attract them is this well. The weak force is actually going to attract these two objects together. Now, you can't really see. It's going to attract because they're going to cross, the wells are going to cross each other. Okay? And once the wells touch each other, it's a force that's going to like kind of pull them together. So, this is basically the beginning of where gravity and magnetism come into play. Space is being stretched out by massive objects, or objects with mass, let's say. A proton has a mass. It stretches out the space around it. Space is trying to get in. So proton's got a mass, and electrons travel around. I think I'm right on this. So what is the electron now? What is that? How does that happen? Well, when an object reaches a certain threshold of mass, okay, we could look per particle. Let's just say an object has a mass 10 times that of one, let's call it a space particle. The space particle, the dark matter, dark energy, whatever, dark matter. It wants to be back in that space. Okay, it's similar, like I said, to putting marble in water. The water gets pushed out of the way, and then when you pull the marble out, the water goes back to its original spot. So the same thing's happening in space, okay, with space. It wants that area. But now, because everything's moving all the time, there's all this movement, particles find each other, find each other's gravity wells, and get attracted. They get pulled in by each other's wells. It's just what happens. They get pulled in, everything's moving all the time. We see it, things are moving all the time. So when these things pass close enough to each other, they catch each other's gravitational well and pull themselves in. A good example of this is, you find a puddle outside after it rains. See the little debris that's floating in the puddle. Most of the time, it's not evenly dispersed. Most of the time, it clumps together. Why is that? Because every little particle has got its own little gravity well. And it just, with the movements of things, and these things are naturally attracted to each other because of their gravity well. Every little thing has got a gravity well. So that's why in puddles you'll see 9 times out of 10, maybe more than that, that debris clumps together. It clumps together. So if we keep this process and we enlarge it, okay, first of all, we got to understand there's a physical aspect to this clumping of objects. When these objects are obviously already moving, okay, so they already have their own momentum. We don't know from where, but they have their own momentum. but now their momentum is sped up when they touch another object's gravitational well. Okay, so that adds an additional force to one or both of the objects. Okay, generally an additional force is described as heat, speed. The speed can increase, or velocity can increase. So when these things come together, they do a rotational dance, and sometimes they can get locked in with each other. They're locked in, they aren't coming apart. It takes massive amounts of effort to separate them. Sometimes we cannot separate them. Sometimes we can, which can produce massive amounts of release of energy, because you are actually dissecting the gravitational well. Okay, you're pulling that gravitational well apart, and what actually happens is you're allowing space to come back in and relax to the area that was there. Because once you have a grouping of massive objects, space just keeps getting pushed further and stretched further and further out. Okay? So when you separate them, space can come back in. And sometimes it can come back in and crash. So anyway, as we build, as we start with one particle and it attracts a second particle, we know we're getting into velocity due to the gravitational pulls provided by the expansion of space. The gravitational pull of two objects pushes space out even further, three objects even further, so on and so forth. So you get space that is being stretched out. Now, what is an electron? What causes an electron? Well, here's another theory. Is space is stretched out so much. Okay. Now, when we see space being stretched out, we've always described it, and tried to describe it as a three-dimensional thing. So it's always a sphere. Things always happen in circles. Okay. We know that electrons travel in a circular path. Okay. So space is stretched out so much. At a point, it's got to have a release. So you got the poles coming out of your particles. Okay, this is actually the comfortable zone. There's still tension, but the poles are where the work's happening. Okay, it's the most comfortable place to be for space to be without breaking. So when you get enough of these massive particles together, massive, anything with mass, and you have the pole, you have the relax point, okay? We know the poles on Earth change, we know the poles on the sun shifts, and it's all due to exterior components. The next solar system, this solar system, they're all applying forces on our solar system. So our sun's poles is our sun and the space around it finding the most relaxing position, okay, to exist. So now we're also, when we're getting into massive objects, we're stretching space out, okay? So in a three-dimensional view, when you stretch space out, it's going to come out like we've seen in those really pretty videos of with trying to show the magnetic lines of a planet and whatnot. So imagine those lines coming out, okay? Coming out in every direction. So if you picture those lines as the stretching of space itself, stretching of space, you will reach certain thresholds where it's got to accumulate, and pretty much a vortice will be created, or a tube around the massive object. This is a breathing point for space itself. It's like space saying, okay, this has got to happen. It's when gravity, the stretching comes to a culminating point where it cannot be stretched anymore, and it starts wrapping itself up. Okay? So this vortice becomes the pathway for an electron, or on a larger scale, for a planet. It's the pathway. It's a vortice that's created due to the mass of the object that it's attached to. And this very easily explains why the planets are specific distances from our sun, why electrons are specific distances from their host. It's a mass thing. It's related to mass. So this vortice now is actually happening all over. Now it can be combined, like as we see in larger sense. Mercury is part of a vortice. Every planet we have is part of a vortice. Okay, a zone where there's too much stretching and it wraps itself up. Creates a tube in the equatorial region of the object. And it's my guess that, and now there's probably research out there to prove this already, but I gotta say it, that should we be in a spacecraft, or whatever it may be, and here's Earth, my head is the sun, and we place a spacecraft in the same vorticular region as the Earth is, on the other side of the sun, it will travel much easier within that vortice than it will outside the vortice. Okay, I believe that vortice is around the entire sun. Okay, it's just the path that the Earth travels in. Now, the Earth may be the culminating point where any of the material that comes into that vortice eventually gets pulled in to the planet. But the vortice, I believe, still remains. So this should explain the mass of an object, how far away the planets are from it. In fact, it should be a calculatable, if we had all the information. We have an estimates on mass of the sun, but really, and the debris field in the area. Now, if there isn't much debris in the area, in the creation of stars and whatnot, if there isn't much debris, you will still have these vortices, okay? These vortices will still exist, even planetless. There won't, if there's not enough material, or it may be a highly energetic, gaseous planet. If there's not a lot of material around, just highly energetic. It's this vortice with not a lot of material in it, but the vortice has to be there. The tube around the equatorial region has to be there. Let's stick with that for now. That's a 20-minute video. We'll go from there.